All right, this goes along with the topic for computing a percentage from a table of values. Okay, so these problems pretty much, the thing that's hard about these is people just, a lot of students forget just how to figure out what a percent is. Well, all a percent is it is a ratio of a part, a specialized part of something to the whole relationship. So like, for example, if I said, what's the percentage of people of teachers at Lane that are redheads, right? I would count how many redheads there are, and there's not many. And then I would divide that by the total number of teachers. So it's the part divided by the whole. So it's the specialized part that you're focusing on, developed by the whole, or divided by the whole population, not developed, divided by. Okay, so in this one, it says, in a survey, 150 shoppers were asked whether they have access to a computer at home and if they have a personal email account. The responses are summarized in the following table. You can tell from some of these problems that these are pretty old because like everybody has an email account now. But anyways, so you're looking at, they set it up as a two-way table, right? So you got, yes, I have an email account, no, I don't. And then, yes, I have a computer, no, I don't have a computer. All right? So letter A asks us what percentage of the shoppers, all right? So that means the shoppers. There's 150 of them. So my whole is going to be 150. So what percentage, what ratio of 150 have computer access at home? So you figure out how many people total have computer access, because we're talking about everybody. Well, you would have to do a little adding, because you got 48 people here who have computer access, who have an email account. You have 12 people who don't have an email account. So you just add 48 and 12. So go up to our calculator, and we go 48 plus 12 equals 60. So 60 people total have computer access at home, but it's 60 out of 150 total, all right? Not a lot, right? So you're going to go 60 divided by 150, and then if I'm doing my calculation right, it should be 0.4, but nope, what am I doing? Let's just hit equals. No. All right, so 60 divided by 150, try that again, equals, yeah, 0.4, right? 4/10. So when you write percentage, what you always want to do, and it gets tricky when you have one that's sort of like this, that doesn't have a lot of numbers, is you move your decimal point over 2 spaces. Okay? Now you might be saying to yourself, well, what's he talking about? There's only 1 space to move it over to the right. Okay? Well, no, you can move it over 2 spaces. You just got to put a 0 after that 4, so to the right of that 4. So if you go 1 space and then another space and put a 0 in there, it's 40%. Another way to do it is if you take this number and you multiply it by 100, that is also how you can come up with your percent. So it's 40%, right? So both ways work. I like the moving the decimal point way because it's just a lot faster. All right, letter B. What percentage of the shoppers have an email account? All right, so these are all the people who have an email account. You got 48 people right here, and you got 3 people right there. So the total number of people who have an email account is 48 plus 3. Okay, so 48 plus 3, so 51 people have an email account. But it's what percentage of the shoppers? So how many of these 150? So it's 51 out of 150. So it's going to be a little more than 1/3. So, I don't know, 34%? That would be my guess, maybe 35. Let's see what we got. All right, 34. So it's 0.34. So if I take my decimal point and I move it over 2 spaces, and I don't have to tack any zeros on this one, I go 1, 2, it's 3, 4 point, right? So 34%. Then we will see if Alex likes our answers. Hey, it does. Let's look at another problem and see if it gives us a trickier one, because some of these are can be a little weird. All right, so researchers asked 150 families whether or not they were homeowners and how many cars they had. So they're asking them two things. So you have one subdivision of people who have like either no car or one car, and then another group of people who have two or more cars. All right, that's how they grouped it. All right, and then they have people who own their home and people who don't own their home. So it's 150 families total, and it says what percentage of the families have no car or one car. Well, the no car or one car is all in this column right here. So it's 9 plus 30, so 39. 39 total people have either no vehicle or only one. So they would say, okay, it's 39, so that's your part divided by your whole. Well, your whole is 150, so we go 39 divided by 150. So 39 divided by, where's that division sign? 150. And click your equal sign. 0.26. Let's try the other way where we just multiply it by 100 and you get 26%. All right, letter B. What percentage of the families, so they mean all the families, don't own their own home, are not homeowners? So that would be this and this. So 30 and 54. So let's figure out how many people don't own their home. So it's 30 plus 54. It's quite a lot according to this. All right, so 84. So you would take your part divided by your whole. So 84 people out of a total possible 150 people, because that's how many people they interviewed. All right, so 0.56. Let's do this one with moving the decimal trick. So move it over 2 spaces. 1, 2, 56%. All right, so a high percentage of people are not homeowners in this group, right? But a lot of them own a lot of cars, which is kind of interesting. You would think that if you had a house, you'd be more likely to have more cars because you have space to put them, but I guess not. All right, so I hope this is helpful to you guys. Good luck with these problems, and remember that you can always use the explanation of the current problem you're on. Keep in mind you'll have to do another one after that, or you can use the example, which will let you still continue to use the attempt you're on. All right, thanks.